Okay, so we wrapped up chapter 11, I think it was 11 now. 7, it's like 11. Um, we're going to go off now to chapter 9, and what we're going to do really in this chapter is sort of put together some of the information that we learned in the previous chapters, which are balancing our equations and grams and moles. And what we're going to talk about is doing calculations from an equation and being able to figure out things like if you know how much reactants you start with, you can figure out how much products you would produce in a particular reaction. You also could kind of go backwards if you know how much products you produced in a particular reaction. You could figure out how much reactants you started with. So the basis of sort of this approach is what's known as stoichiometry. And people get sometimes freaked out about stoichiometry, but it really is just a conversion factor. And unlike sort of going to a table to find a conversion factor like 12 inches equals a foot or something like that, where we actually get the conversion factor from is the balanced equation. So we use the balanced equation to get these conversion factors. And what we use from the balanced equation is the coefficients. So those numbers that we put in front to balance the equation, we use these as really conversion factors. And for example, if you have an equation such as the one up here, you could look at those coefficients, for example, and say you have 2 molecules of H2 react with 1 molecule of O2 to form 2 molecules of H2O. The relationship that we use pretty much solely with stoichiometry is actually this next relationship and is sometimes referred to as the mole to mole relationship. And we could also just use the coefficients and say for every 2 moles of H2, we react 1 mole of O2 and gives us 2 moles of H2O. So there is no magical thing here in terms of where we're getting those numbers. It simply is just the coefficients from the balanced equation, and that's where those sort of numbers come from. The last relationship here is the conservation of mass. So as we know in a chemical reaction, we do not replace any elements. No new elements are formed. All we do is break bonds and make new bonds. So if we started, for example, with 2 oxygens on the left, we should also end with 2 oxygens on the right. And since oxygen has a mass of 16 grams per mole, on the left and right, we will end up with the exact same mass of reactants and products. So that's a conservation of mass. So really with stoichiometry, we are going to use this sort of relationship here, this mole to mole relationship. So let's talk a little bit about this idea. As I mentioned before, what stoichiometry allows you to do is figure out if you produce a certain amount of product, how much of those reactants you started with. It also allows you to figure out if you start out with a certain amount of reactants, how much product you will actually form. So we could actually do stoichiometry for anybody in the equation. And what it allows you to figure out is if you just know really one piece of information, you can figure out the relationship of everybody else. So, for example, if we have this equation here, we could do stoichiometry and relationships from, say, our reactants to our products. We could also go from our products to our reactants. And sometimes people always think when they do stoichiometry that you always need to go across the arrow to do so. You could also do stoichiometry between 2 reactants. So you could do this type of calculation between 2 reactants, and you could also do it between 2 products as well. So you could apply these sort of calculations we're going to talk about to really anybody in the equation. And this is sometimes helpful, for example, if you figure out how much of one product you produce, you could then use stoichiometry just to quickly figure out how much of the other product you would produce as well. So these are usually the questions that we look to answer. Now, in terms of units that we use in these type of problems, there really is a bunch of different units that we use. and we will see them as we continue on in further chapters. We will use some different units with stoichiometry, but the basic calculation is really the same. We could have units of moles, grams, liters, or really any type of unit. The basic stoichiometry ones, like we're going to kind of talk about kind of in this chapter, revolves around a calculation that we've done before, which is grams to moles. And that calculation, and remember that if you want to convert from grams to moles, or even going backwards, moles to grams, we use the molar mass to do so. And the molar mass from the periodic table is grams per mole. And we could use that as like a conversion factor as well. We can flip it around and do dimensional analysis from it. So we use this periodic table molar mass as a very common conversion in stoichiometry problems. In fact, I would say that probably the second step in these type of problems is always, or in a lot of cases, is taking grams and converting them to moles. And the reason you need to kind of do this calculation a lot in stoichiometry is the basis of what we're doing is using mole to mole relationships. So you kind of have to convert the numbers that they give you into moles so everything will cancel out sort of correctly. There are a few steps to follow when you do these type of problems, and really they can be broken down into kind of 4 steps. These kind of outline an extra step along the way, and it all really starts with the equation, and you definitely want to make sure you are starting with a balanced equation. So if you try this calculation without a balanced equation, you're going to be in trouble because your calculation is going to be wrong. So what that means is you could either have to do step 1 or step 2 here, but if you are given the equation, you should definitely take a look at it and make sure that it is balanced before you go any further. If you're asked to write the equation, like we've been talking about with our last couple of chapters, you want to make sure that you write all the formulas down first and get all the proper formulas, and then you want to balance it. So whatever you do, you got to always basically start with a balanced equation in this case. The second step after you basically balance the equation is in a basic stoichiometry problem, they basically will give you one piece of information. And it may be like something about the reactant, something about a product, whatever it may be. Whatever unit that is in, you want to then get it to grams, and then you want to go from grams to moles using the molar mass. I would say very commonly the units will be grams to begin with, but just in case they are not grams, you need to convert them to grams and then do the molar mass conversion to convert it to moles. The whole purpose of this step here is to get whatever number they gave you into moles, because you will need that number in moles in order to actually do the calculation and the stoichiometry. The third step here is the mole to mole relationship. And that comes from the balanced equation. And we're going to talk about what that looks like in just a second. But you will go to the equation at this point, and you will find really the 2 things you're interested in. And one thing that you're interested in is whatever they gave you. So somewhere in the problem, they gave you a number. So whatever that thing is one of the things you're interested in. The other thing that you're interested in is what you're trying to find. So maybe you're trying to find the grams of a product, or maybe you want to find the grams of a reactant. So the other thing that you're looking to find is the other thing that you want to find in that relationship, and you want to find that mole to mole relationship. Lastly, the 4th step is you should always be in moles at this point. You then want to convert it into some other unit. And I would say commonly you will probably be going a lot of times moles back to grams. So again, on the back end of this calculation, we will use molar mass a lot again. So we kind of use molar mass on the front end of the calculation. And a lot of times in these basic stoichiometry problems, we'll use that molar mass conversion to take it back from moles to grams. Any questions on that? So the first thing you should think about is really just these 4 steps. You should always follow these 4 steps in the order, and it should get you to the answer that you're looking for. So let's take a look at an actual equation. So let's say we have this equation here. I think I'll just write it a little bit higher. 2CO plus O2 goes to 2CO2. All right. So what we want to look at with this equation, obviously, is to make sure that it is balanced, and it is. We can get several different relationships from the actual equation. So we could see from the equation that looking at the coefficients, for every 2 moles of CO, I get to react it with 1 mole of O2. And again, those are just the coefficients from the balanced equation. Obviously, like normal, if nothing is written there, it is assumed to be 1. I could also say that for every 2 moles of my CO that I put in there, I am going to get out 2 moles of CO2. I could also say for every 1 mole of O2, I will get out 2 moles of CO2. These are all equalities. They're sometimes referred to as stoichiometric equalities. They are not equal to each other in terms of, obviously, 2 does not equal 1, nor does 1 equal 2 in this sense. They are equal to each other in terms of proportion of what you need to put into that reaction to get out the products. So if you were like baking cookies, right, you need a certain amount of flour you got to throw in there, some butter, some sugar, some chocolate chips, right? You have to throw a certain proportion of all these things in to get out like a dozen cookies, 2 dozen cookies that come out. And that's what we're basically looking at here. These are the proportions of our reactants that will need to be kind of put into this equation to produce a certain amount of product. Now, because these are equalities, just like we talked about at the very beginning of the semester when we were doing conversions, you could actually write 2 conversion factors for each of these. So for each of these equalities, we could actually come up with conversion factors that we could use. So for example, here, our first one, we could write there are 2 moles of CO over 1 mole of O2. Or we could flip it around like any other conversion factor, 1 mole of O2 up on top, 2 moles of CO on the bottom. For the second one, we could write 2 moles of CO on top, 2 moles of CO2 on the bottom, are 2 moles of CO2 up on top and 2 moles of CO on the bottom. And lastly, we could write for that relationship 1 mole of O2 up on top and 2 moles of CO2 on the bottom, are 2 moles of CO2 up on top and 1 mole of O2 on the bottom. So from this one balanced equation, we actually have 6 different conversion factors that are available to us to use. Will we use all 6 in a calculation? The answer is no. You're probably just going to use 1. But you do have available to you 6 of them to choose from. And you want to think of this really as stoichiometry, nothing more than a conversion factor. And again, where we get the conversion factor from is the equation rather than looking it up in a table or something like that. So let's take a look at an example here just to demonstrate how we would go through our process of our 4 steps here. So let's say, for example, we produced, in this case, 13.5 grams of CO2, and we want to know how many grams of O2 did we basically start with to produce that much. So, first off, we want to go through our kind of 4 steps. The first step is done for us already. It is balance the equation. So, the equation is balanced, so we're good to go on that. You definitely always want to make sure if it is balanced or not. So, that is all good. The next thing that we want to do is we want to look at what was given to us in the problem and we want to convert to moles. So step number 2 is to convert to moles. And in this particular case, we do need to do that because the only piece of information given to us was grams of CO2. And we can convert into moles by using the molar mass. So we would have to go to the periodic table and calculate the molar mass of CO2. That would be 1 carbon at 12.01 from the periodic table plus 2 oxygens at 16 from the periodic table. And that's going to give us 4401 grams per mole. So that is the molar mass that we could get again from the periodic table. And we're going to use that as a conversion factor. So the second thing that we'd want to do is take our 13.5 grams of CO2. Remember, we'll just do a little dimensional analysis. So grams are on top. So we do need to flip our molar mass and put the grams of the molar mass on the bottom. So 4401 grams per mole of CO2. We're going to multiply the top and divide the bottom. And that's going to give us our moles of CO2. So we're going to multiply and divide. Yeah. So 13.5 divided by 4401 is going to give us 0.3067 moles of CO2. First off, any questions on that calculation? That is the same calculation that we learned about, I think, in chapter 8, if I'm not mistaken. Again, just grams to moles using the molar mass. The whole purpose of really this step is to get your number into the proper units so that we can actually do the stoichiometry part of the calculation. So we are now ready for the stoichiometry part of the calculation, which is we want to go for our mole to mole relationship. So what I'm going to do is go to my balance equation and I'm going to find the 2 things I'm interested in. Clearly, I am interested in CO2 because that is what was given to me. I am not interested in CO2 as my ending answer. I am interested in finding about oxygen, which is this guy. So these are the 2 guys that I am interested in here in my equation. That gives me a relationship that we talked about a second ago. It gives me this relationship right here from the coefficients. That for every 1 mole of O2 I put in there, I get out 2 moles of CO2. That gives me a choice of 2 conversion factors that I could use in this problem. And the one I want to use is the opposites cancel. So right now, I have moles of CO2 and I want to get rid of them. So CO2 would be on top, which means in order to get rid of the CO2, I would have to use the conversion factor here on the left because that has the CO2 in the opposite location. So to show you how that works, we're going to take our number from the previous step, which is our moles of CO2. Again, it is on top. So we will use our conversion factor there. 1 mole of O2 up on top and 2 moles of CO2 on the bottom. This again comes from the balanced equation. And that right there is the big stoichiometry move, that conversion factor that you are using in this point. Again, we're going to multiply the top, divide the bottom, and we will get moles of CO2 canceling. So we're basically just going to divide by 2, and we will end up with 0.1534 moles of O2. The purpose of this calculation is to get us from CO2 in this case to O2, which is what we're interested in. So we need some type of conversion factor to allow us to do that. Any questions on that there? All right, in this case, we are not interested in moles. If we were happen to be interested in moles of our O2, we actually would be done with the calculation. We could have put a box around it. But we're actually interested in grams, and we do have to do the fourth step here, which is go from moles now to some other unit. And in this case, we are looking at O2. So we have to go back to the periodic table here to get the molar mass of O2, which is 2 times 16. And that's going to give us 32 grams per mole as our molar mass. And we will use that to finish out the problem here. We'll take our number from above. We will use our molar mass and put the grams up on top so that we do end up with grams per mole. The moles are going to cancel, and that's going to get us here our answer of 4.91 grams of O2. The significant figures would come from the original number, which was 3 significant figures. Everything else there is kind of an exact number. So these are the steps for a basic stoichiometry problem. Balance the equation, convert whatever they give you to grams, and then grams to moles. Go to the equation and find that mole-to-mole relationship, and then go from the mole-to-mole relationship or the moles to some other unit. Now, I did this all in parts, but you could, if you wanted to, do it all in one calculation. You could go from here to here to here and just do it all in one calculation if you want, without getting an answer in between. If it's easier to get an answer in between, you should get an answer. And again, I would avoid rounding too much along the way if you do get an answer in between. So take it to a few digits or so. Question on those steps there, yeah. So this is a really important sort of calculation, and we will use it in a lot of places, including this chapter and multiple chapters down the road as well. But the basis pretty much of all stoichiometry calculations are these 4 steps here. Oh, any questions on that there? All right. All right, so I'm going to lay it up there. I just want to kind of introduce the idea of stoichiometry.